Let's take a look at this homework set here. So, what I was looking for. We see that the stock is currently trading at $10. So, throughout this whole thing, it's a $10 stock, and it can go up to 12 with a probability of 0.3, or down to 9 with a probability of 0.7. So right away, it's not log normal, because log normal would mean you take the 10, multiply it by 1 plus x, and take the 10 and multiply it by 1 minus x to get those two prices. So either x has to be 0.2 if it's going up and 0.1 if it's going down. So it's not moving at log normal. So we can't use that formula that you would use for the tree, let's say. But now let's see what our questions are. The expected value. So the expected value, that's just going to be, it's a 30% chance that it's $12, and it's a 70% chance that it's $9. So its expected value is 9.9. The variance. Okay, so this is, I'm going to call that the expected value. For the variance, I want to get the expected value of the stock squared. So if it goes up, it's 12 squared, that's 144. If it goes down 9 squared, that's 81. So this would be the expected value of the x squared, and I want to subtract from that the expected value of x squared. That'll give me the variance, and I'm getting 1.89. Next question then. What's the value today if we're talking about a call option, and I want to use that that portfolio, buy an option, short some shares. So let me change the color here for a bit. So we're talking about a call with an exercise price of $11. So if the stock goes up, that option's worth $1. If the stock goes down, that option's worth 0. So in the up case of the future, you've got V minus delta times 12, and in the down case of the future, you've got 0 minus delta times 9. You set these two futures equal to each other and solve for delta. If I do that, I'm going to get delta equal to a third. So I set 1 minus delta times 12 equal to minus delta times 9 equal, you get delta equals a third. That means I need to short a share. That means that when I bought the portfolio, V, that's the price I'm solving for, minus delta, now I know what third is, I know what delta is, it's a third, times the current stock price 10, that's supposed to equal to, now there's no time value of money because we set the risk-free rate equal to 0. So it's equal to either one of these up or down values. Let's do the down, because minus a third times 9 is just minus 3. So the portfolio should be equal to minus 3. When I solve for V then, I get V minus 10 over 3 equals minus 9 over 3. I'm getting a value for the option at being 1/3. That's not the delta, that's the price of the option. 1/3 minus 10 thirds is minus 9 thirds, and that's minus 3. All right, what's the expected value of the call option? That's the next one down here. I won't scroll, but because I've got all the stuff up here to fix it. The expected value, well, there's a third of a chance that the value is 1 and 70% chance that the value is 0. So I'm using this expected value here again, but this time I'm not putting in the stock, I'm taking the expected value. So 30% chance it's 1, 70% chance it's 0. That makes the expected value of the option 0.3. Its actual value is 0.333 repeating. It's different. Yeah, we don't price things at expected value. So expected value of the call option. All right, this last question here. Now we got to we got, what's the value today of a straddle? So, okay, what's the value of a straddle? Well, let's redraw then. You get $10, goes up to $12. I'm not writing the probabilities because they don't matter in this case. Down to $9. Now, a straddle with an exercise price of 10. That's a put and a call. If the stock goes up, then our straddle will just be, the put will be worthless and the call will be worth $2. If the stock goes down, the call will be worthless and the put will be worth $1. So here's our V plus and our V minus. So we can calculate what the delta is. So I'm jumping, I know we're going to set up that portfolio, but we had our delta formula as V plus minus V minus all over S plus minus S minus. So I've got all those information. I've got all that information here. I can calculate that the delta is equal to, okay, 2 minus 1 over 12 minus 9. It's equal to a third. The delta in this case is also equal to a third. Coincidental that it was equal to a third before. So that means I'm going to short 1/3 of a stock. So my portfolio, up or down, what's it worth? Let's look at the down part. That would be V minus 1/3 times the stock value. So that would be minus 2. So the portfolio should be worth minus 2. If I would have chosen the top, and you can check that, if I would have chosen the top positive stock value, I would also get a portfolio of minus 2. So the portfolio should be equal to, V, that's the straddle price, we don't know what that is yet, minus 1/3 10, and that's equal to no time value of money, so that's equal to minus 2. Solve that for V, and I should get 4/3. That means the straddle is worth 4/3. How many stocks do we short? They're just asking me for the delta again. I should have put a box for that. So now I know a straddle, the fair price for a straddle is 4/3. This is going to help me out on the next question. So I know the value of a straddle. I know, let's make note to self. The fair price should be 4/3. But we see that calls are priced at 2/3 and puts are priced at 4/7. So if I add that together, let's do everything in terms of 21s. If I add that together, then I should get the, the fair price of a straddle, the market price, what it's buying for. So that ends up being 26 21s. We calculated in 21s that it should sell for 28 21s. So they're selling for 2 21s cheaper than they should be. So I should buy a straddle. Well, since I want the portfolio, let's look at the portfolio. The portfolio is equal to V minus delta, and I know what the delta is, stock. I should, since I want to buy the V part, I'm going to buy the whole portfolio. So I'm going to short a share of $10 stock. So step one is somebody gives me 10 over $3, and I owe them 1/3 of a share. I take some of this 10 over 3, and let's just write this as like 3.33. And no, let's not write it like that, because I'm doing everything in terms of 21 just to keep the fractions nice, because we can. So that's going to be 70/20. So somebody gives me 70 21s worth of monies, and I got to buy one of these straddle options that cost me 26 21s. So that means I'm going to buy a V, and now I have leftover cash. What? I got 44 over 21s leftover cash. So this is in step 2. I got a V I got some cash. Oh, and I still owe a guy 1/3 of a share. Now what happens? Well, either the stock goes up to 12 or the stock goes down to 9. Let's just say, what if the stock goes up to 12? So now, if it goes up, I owe 1/3 of a share. That's going to cost me minus $4. But my option is worth $2 now. My straddle is worth $2. So I could cash in my straddle. I'm still $2 short. Oh, but I have $2, and $2 would be 42 over 21. Plus I have another 2 over 21 cash. So this settles out, meaning that minus 4 plus 2 plus 42 over 4 equals 0, and I have a 42 over 4, that's 42 over 21, and I have two 21s, the difference between the 28 21s and 26 21s, profit, free. What if the stock goes down? Well, if the stock goes down, then it's down to $9. I only owe minus $3 in that, I owe 1/3 of a share. My option is worth $1 in this case, the put part, and that's still minus 2. Yeah, that was the portfolio. It was going to be worth minus 2. I still have the 42 21s plus the 2 21s. I pay my debt, and I still have the 2 21s left over. So I make the 2 21s guaranteed. I make it regardless if the stock goes up, if the stock goes down. All right, now let's look at the last part here. Was talking about using weekly adjusted closes. So I go to Yahoo Finance. I get our data. I've already eliminated, so I've got my GM data. It's weekly. I've already eliminated all the columns except for the adjusted close. That's the one I need. And then I need to create my returns. So the return is what the stock is tomorrow, or what the stock is minus what the stock was yesterday, divided by what I paid for it yesterday. So it dropped in this case. It dropped like 0.3%. Oh yeah, it was 34.34 and now it's 34.23. It's a negative return. I get all those returns and I need to calculate the drift. So I'm taking the average of those returns. Now those are weekly, so I want to scale it up by multiplying by 52. I get a drift of 0.7. Now I want to talk about the risk. I want to get the volatility. I take the standard deviation of the returns. Notice it's the one with the S, not the P. I want the sample formula. Standard deviation of the returns, and I want to scale that up because I want to express it annually, so I'm multiplying that by the square root of 52. So the volatility should be about 0.71-ish, and the same with the drift. It's weird or unusual that they're the same. Usually the volatility is way bigger than the drift, but in this case, it's not.